All right, have you ever really thought about how you could create something from, well, from literally nothing? I'm not just talking about empty space. I mean a space before space even exists. Sounds kind of mind-bending, right? Well, let's dive right in, because today we're going to explore this really cool concept called generative geometry, where things, entities, are literally born from pure logic.
Okay, so to get started, I want you to just erase everything you think you know about space. Seriously. Forget X, Y, and Z axes, forget up, down, left, or right. None of that exists yet. We're starting in what the source material calls spatio, and really, you can just think of it like an infinite blank sheet of paper. There's no grid, no orientation, absolutely nothing. Just a perfect void.
So, that's the big question, isn't it? In a universe of just nothing, how does the very first something pop into existence? I mean, where do you even begin when there are no rules to follow? Okay, so let's take that first step. From nothing, something. Before we can build anything at all, we've got to do something kind of foundational, a creative act. We need to break that perfect empty symmetry of the void with one simple, powerful statement.
And, it's really important to get what this spazio is all about. This isn't the physical universe we live in. No, it's a purely logical space, a relational one. What that means is the position of things isn't defined by coordinates on a map, but by how they relate to each other. We're basically in a universe that's going to make up its own rules as it goes along. All right, the first axiom. So to bring any kind of order to this emptiness, we need what's called an axiom. It's just a fundamental truth that we decide exists. We just declare it. This is our starting point, the very first ripple in that conceptual pond.
And here it is. The first creative act is just a simple declaration. Using the syntax from the source material, it just looks like this, exclamation point A. Now, this command doesn't place A anywhere specific because there is no anywhere yet. It just asserts that A exists. And just like that, with one little statement, we've made our very first entity. The void isn't empty anymore.
But, one single point in an infinite void, it's kind of lonely, and it doesn't really mean much. To define anything, like distance or direction, you need something else to compare it to, right? So we do it again. We perform another one of these axiomatic acts and declare a second entity, exclamation point B.
Okay, let's put a formal name to this. These fundamental points of existence, these little somethings we've just created, are called instances. And a good way to think of them is like the indivisible atoms of our brand new universe. Every single thing we're about to build, from the simplest little line to the most complex structures you can imagine, is going to be made from these basic instances.
Section 3. Defining distance without numbers. Now, this is where it gets really interesting. We have two instances now, so we can finally establish the very first law of physics for our little universe. And here's the cool part. We're going to define what distance means without using a single number or a ruler or any kind of coordinate system. How cool is that? So, the simplest possible relationship you can have is an instance just relating to itself. It's basically a loop. In the language from the source, this is called a self-relation, and it's written as &ra. This is really the most basic concept of identity, a thing knowing it exists.
But the real game changer, the truly generative step, is connecting two different instances. When we formally link our A and B together, we create our very first binary relation, which is written as &RR. And you gotta understand, this one single connection is the very first meaningful structure in this whole new universe.
And this is a super important point, so really lock this in. A relation, this relazione, it's not just a line you draw between two dots. It's a formal rule. It is a definition. It captures the specific spatial pattern between those instances. And this idea that a relation is a rule, that's the key to absolutely everything that's about to happen.
This really shows the difference perfectly. So in the normal coordinate space we learned in school, right? Distance is something you calculate based on a grid that's already there. But here in this relational space, that very first relation we made, the &R, it becomes our unit of measure. It doesn't measure the distance, it is the distance. It's like we've literally invented our own ruler from scratch, just out of pure logic.
All right, Section 4, generating a linear world. Okay, this is where the magic really starts to happen. This is where our whole system comes alive. We've got two instances and one rule. So let's see what we can build with that.
Okay, so here's how it works. Check this out. We start with our two instances, A and B, and they're connected by our one rule, that relation RR.
Now what we do is we take that rule, that very specific distance and direction, and we apply it again, but this time we start from B. And poof, the system generates a brand new instance, C, that perfectly maintains that same relationship. Then we do it again from C, and we get D. And you can just keep going. By just repeating one simple rule over and over, we've generated a perfectly straight, perfectly ordered, one-dimensional world completely from scratch.
Now, this whole generation thing is obviously really powerful. But the biggest idea here, the most profound part, is what that relation actually represents. It's so much more than just a command to make the next dot in a line.
You know, the source material says it perfectly. La relazione lega gruppi di stanze in un pattern. Tramite la relazione si possono generare altre istanze. And that basically just translates to, the relation binds groups of instances into a pattern. Through the relation, other instances can be generated. So you see, it's a pattern maker. That's what it is.
And this is the big takeaway. This is the whole thing right here. That relation R and R, it didn't just connect A and B. It captured the abstract idea of a very specific distance and direction. It's become a reusable concept, almost like a piece of spatial DNA, that we can now use anywhere we want to build consistent, ordered things.
So think about it. We started with absolutely nothing. We declared 2 points into existence and defined just one relationship between them. And by treating that relationship not as some static line, but as a dynamic, reusable rule, we've unlocked the power to generate a whole world. It really leaves you wondering, right? What other more complex rules could we capture? And what kind of universe could they build?